Hi everyone. So, welcome back. And in today's video, we'll be talking about implications, right? So, first off, I want to explain what is an implication. What is an implication? What does it mean to imply something, especially in modern English, right? What does it mean when we're implying something? Well, an implication can simply be if this happens, then this must also occur, right? So it's basically an if and then, right? So an example in modern English would be if rains, then rainbow, right? So if we know that it rains, then we must conclude that a rainbow must appear, right? Um, this is just a simple implication, right? And how we can apply this to math would be if we have two statements, which are statements, we can write an implication mathematically as this, where we know this means implies. That symbol with the two lines and that with the arrow means implies. So again, going back to our example, which is if rains, then rainbow, we know that this part is A and this part is B. And then, because we're saying that if A occurs, then we're implying that B occurs, right? I hope that makes sense. And so we can also write this in like the notation that I just mentioned, the math notation right here, which would give us rains implies rainbow, which makes sense. It's a fair judgment. Now, what is another way of thinking about this? We can think of A as a hypothesis, right? Because you're saying, if we assume this occurs, so we're saying if this, then this, right? So we can think of A as a hypothesis. Well, if we're thinking of A as a hypothesis, then that makes B our conclusion. Because if we're assuming A is true, or A is has it whatever the truth value of A is, if we're assuming that, then we must have something that we're going from there, like we're using it as a foundation and working off of it, right? So it must have something that we're branching off to. And again, I'm going to show a truth table. And this is content working off of last week's as well, because truth tables and truth values and all of the content covered in last week's, in last episode will, not last week, my bad, in last episode will be very, very important going forward. So suppose I make a truth table like this, right? Well, I want to show you something cool. I want to show you something which is a much more easier way of proving, of showing implications. Technically speaking, we can write an implication, so we can say A implies B is logically equivalent to, what can we say it's logically equivalent to? Well, we know that it can be logically equivalent to this other statement, right? Which is negation of A or B. It may not make logically much sense, but we can say this. We know we know this. This has been proven before. So now that we have this, it's easier to find our truth value, right? For A implies B, because we can just say that it's this, right? Well, if we know this, right? Well, negation of A, so negation of true, is just false. False or true gives you true. And now false or false gives you false. And then I negate the false, you get true. True or true gives you true. And you negate the false and you get true or false. So you get true. And this indeed is the truth table for an implication. Now there's a couple more things I would like to talk about. First, let's talk about the negation of an implication. Right? So you might look at it and you might be like, well, how would I negate an implication? How would I go from this to finding this, right? Well, here's a very, very nice trick. As established earlier, this is the same as saying this, right? So we can say that it's, oops, my bad, that. And then we can just find negation of negation A or B, right? And from here, we can use our theorems that we learned last week using the laws, right? And then we get, well, negation of a negation is just A and negation B, right? Well, now we have this, and now it should be much more easier to make our truth table, right? And then we get negation of A implies B. So if we have true, true, false, false, true, false, true, false. Okay? There we go. So if I have true and true, right? So I have true and false. So this would give me false because I negate this, right? If I have true, true, and negation of false, which just gives me true, I get true. If I have false and negation of true, which gives me also false, so I get false and false, so I get false. And here I get false and negation of false, which gives me true. So false and true, again, gives me false. And if you look at it, these definitely are opposite values. So here is true, false, true, true. Here it's false, true, false, false. So there, it's definitely a negation of just these values right here. Okay, so that's the negation of a statement, of an implication statement. Well, you might think, I don't understand this, like conceptually. Like you might know, yeah, I know how to calculate it, I know how to do this truth table stuff, but I don't understand the concept of a negation. Well, again, you can think about this. So applying it to our example again. Our example, right? Our example was if rain, then rainbow. It was rain implies rainbow. Well, if we negate it, right? If we negate it, then we're saying this, then we're saying no rain, right? So we're saying rain and no rainbow, right? So earlier we're basically saying if it rains, that means there will be a rainbow. And now what we're saying is it'll rain and there's no rainbow. So earlier we were saying if it rains, there will be a rainbow. Now we're saying it rained, but there's no rainbow. So it's kind of like a reverse situation of what we had earlier, if that makes sense. Now we'll talk about the converse. The converse of an implication. Again, if we have a statement that looks like this, where A and B are statements and A implies B, the converse is just B implies A, right? This one's not that hard to understand. It's just a very basic statement. It's just saying that you reverse the statement's positions, right? So again, applying it to our example. We get that if rain, then rainbow. And flipping this, we get if rainbow, then rain, right? Now, one thing we must keep in mind. A implies B is not necessarily logically equivalent to B implies A. And you might say, why? They're the same statements. It's the same type of idea. Well, if we were to make a truth table, right? So if we have A, B, A implies B, and B implies A, right? So if they're the same, then the values here should be the same as the values here. And now we'll see that. Let's put it into test. Right? So if true implies true, we get true. If true implies false, using a truth table from above, we get false, right? If false implies true, we get true, and if false implies false, we get true. Now here's backwards. True implies true, we get true. False implies true, we get true. True implies false, we get false. And false implies false, we get true. So see these two lines, right? So these two lines are where it's flipped, right? So that's what we can say that they're not logically equivalent. Okay, moving on. Now we're going to talk about the contrapositive. So the contrapositive states that it's similar to the converse, except a little bit different. So if we have a statement that's A implies B, then the contrapositive is the negation. It's similar to negating both your statements and putting them as the converse. So here we had B implies A. Now we have negation B implies A. They're a little bit different. Because now you negate it. So if I were to apply this to my example, which is if rain, then rainbow, I would get no rainbow implies no rain. And let's make a claim. Let's say A implies B is logically equivalent to the contrapositive, which is negation B implies negation A. Alright, so we're saying that they're logically equivalent. Why? Again, let's test it out. Oops. Implies negation A. Right, so we have true, true, false, false, true, false, true, false. So true implies true is true, true implies false is false, false implies true is true, and false implies false is true, right? Here we get false implies false, like, so we negate this and we move backwards. We get false implies false is, well, true. True implies false. We get false, right? Because we negate both of them. False implies true. We get true. And true implies true. We get true. So see, our values are the same, which means they are logically equivalent. So now that we've discussed contrapositives, we've discussed converse, we've discussed negation of an implication and what an implication is, now we're going to move on to something called a double implication, or it's called an if and only if, right? These statements have a form that looks like this. And you might be thinking, what? I'm confused. Oops. You might be thinking, what does this mean? Well, as the name might suggest, double implication. And we know what a single implication is. Single implications look like this. A implies B. Now what about a double implication? Right? Well, we have something called a forwards and a backwards. So if we know that our forwards is equal to this, what would our backwards be? Well, our backwards would be B implies A, right? Well, if it's a double implication, so I have two implications, well, how do I put them together? How can I unite them together? Well, here's it is. So a double implication, therefore, we have A implies B and B implies A. And that is your double implication, or your if and only if. So A is the same as a normal implication plus the converse. I should maybe not use plus, I should use and the converse, because that's all this is. Now let's apply it to our example. So if we have rain, double negation, rainbow, this means rainbow implies rain and rain implies rainbow. This means there must be a rainbow. This means if there's a rainbow, there's rain, and if there's rain, then there's a rainbow. So if both conditions are true, it is, double implication is true. Now, what does this mean? So if rainbows only occur when it rains, and whenever it rains, there's a rainbow, that means that this makes the implication true, the double implication true, because it has to rain in order for the double implication to be true. Okay, so now let's take a look at a truth table for this. Right? Okay. And again, this is the same thing as saying a double implication B, right? So again, we have true, true, false, false, true, false, true, false. Now, what we can do is we can actually cheat a little bit, right? If we use this, we know our forwards implication, so we know true and true will give us true. We know false and true would give us false and true would give us false, right? Again, true and true. Oh, wrong one. True and false would give us false, and false would give us true, right? Because we have false, and you get true and true. So only true when A is logically equivalent to B. And that might be very useful, because only when B and A are both true, it will be met. So in this case, it would be if there's a rainbow and it rained, it would be true, right? So it's only true if either there was no rainbow and it didn't rain, or it rained and there was a rainbow. So both conditions must be met. Okay, so that's all for today's episode. In next episode, we will be going over some basic proof techniques to solve some beginner level proofs. I hope you enjoyed this video and I hope it helped. Please leave your comments down below and I will attend to them. And if there are any concerns, then I will also take a look at them potentially in the future episodes. Thank you.